Students, let us go ahead with a few more problems of congruency. So, let us have a look on the problem. In the given figure, prove that triangle ADB is congruent to triangle AEC and triangle EBC is congruent to triangle DBC. It is given CE is equal to BD. That means these two lines, the altitudes are equal, and BD is perpendicular on AC and CE is perpendicular on AB. So, we start marking. I will mark this angle also should be 90, this angle should also be 90. This angle will be common in triangle ADB and triangle AEC. For the beginners, those who are learning congruency, you should take this triangle out. ADB I have taken out. You should take this triangle out. ADB I have taken out. Alright. Let us see. ADB I have taken out. Let me use a little darker pen. Let me try. Okay. So, ADB I have taken out. ADB, and I will mark this, and then we have also taken out AEC. So, then we mark what we know. So, BD, this angle BDA is 90 and angle CEA is 90. Angle A is common in both, and then this is, wait a second, now what is happening? Let us see. Now they are giving you, yes, BD is equal to CE. That is what it is given. BD is equal to CE or CE is equal to BD. So, now let us have a look. This triangle I have snatched and kept it here. Your size is little smaller because of the use, otherwise exactly you can take it out. And then what happens? Now we can see these two angles are equal and none included sides are equal. So, obviously both the triangles, that is ADB and AEC, will be congruent by angle and none included side, that is AAS. So, now it is easy for us to write in triangle ADB and triangle AEC. What happens? Angle A is common in both, common. Now, angle ADB is equal to AEC, angle ADB is equal to angle AEC, each 90 degree. Alright. Then what happens? Then BD side is equal to C, it is given. So, triangle ADB should be congruent to triangle ADB is congruent to triangle ADB is congruent to triangle AEC by AAS, and once they are congruent, they are equal in all respect. So, we can even prove that AB is equal to AC. That means this triangle is isosceles. The question can come that prove that the triangles are isosceles. Number 2 is now we have to prove the triangle EBC. So, I am taking it out. So, this part is done. So, I am taking out EBC, So, this angle is 90 degree, and I am taking out DBC. Now, you see these two sides are equal, and also it is given BD is equal to C. So, now what criteria is there? This will be right angle, hypotenuse equal, and one of the sides of each are equal. That means by RHS both the triangles are congruent. So, what we can write over here is, in triangle EBC and triangle DBC, base BC is common. Alright. C is equal to BD, it is given, and angle BEC is equal to angle angle BDC, BEC is equal to CDB, is equal to angle CDB, each 90 degree. This proves triangle EBC is congruent to triangle DBC by EBC is congruent to triangle EBC is congruent to triangle ECB is congruent to triangle EBC is congruent to, let us see, EBC is congruent to DCB. EBC is congruent to DCB by, alright. Let me try to see here. I am trying to be reluctant to write straight away. E is 90, so E is 90, D is 90, vertex match. B over here is this angle, so C will be the other side, counterpart of it. So now it is done. Next question is even more interesting. This is used a lot of places. They say prove that any point on the angle bisector. So first we will make an angle AOB and then we will make the angle bisector. So they say angle bisector means, let it look like an angle bisector. These two angles are equal. So they say any point on this line will be at equal distances from the two arms AO and OB. Now what is the meaning of equidistant? If you stand over here, the perpendicular distance they are telling to prove the perpendicular distances are equal. That means we have to prove that OM is equal to ON. Anywhere if we put not OM is equal to, we will put PM is equal to PN. Now any point, if P was here still we can prove this, that anywhere you stand you are always equal distance from the both the arms. Why it happens? Because you get two angles equal and the hypotenuse becomes common. So by AS the two triangles are congruent. So here we will write down, let AOB be an angle and let OX bisect angle AOB, let P be any point on OX. We draw PM perpendicular on OA and PN perpendicular on OB. So we have to prove that PM is equal to PN. So we will prove it through congruency in triangle POM and triangle PON. POM and PON, what will happen? Angle POM is equal to angle PON. It is given, angle bisector. POM is equal to PON, isn't it? Then angle PMO is equal, you will concentrate on the drawing, PMO is equal to PNY. Why they are equal? Can you tell? PMO is equal to PNO. What does the sign say? It is 90 degree. And PO is common. So by AAS, triangle POM is congruent to, triangle POM is congruent to triangle PON. This implies that, this is by AS we have written, this implies that PM is equal to PN. So if this point was shifted here also the same result would have happened. This is to be used in my later congruency. This is a very, very important theorem.